Like trigonometry, Jay?
Yes. All right, here we go. So example 4, and I believe I asked you to try this one. It says, sketch the graph of y equals 2 cosine the quantity x plus pi over 3. So in example 4, this is not new from yesterday. This is just like reinforcing what we did. So I've got my parent function. I'm going to create a table with my 5 key points. And when I do cosine,
Do you mind if I borrow one of these pencils?
no, you'll just need to sharpen it though, because I just put new ones in. I have a sharpeners right here. All right, so when I do cosine, where does cosine start at 0? What's the y value? Not 0. It's at 1, okay? Look here at the chalkboard. I put, if you start at 0, the cosine of 0 is 1. It's the x value. So that's 1, 0, negative 1, 0, 1. The domain for all sine and cosine graphs are negative infinity to infinity. I like to wait to do my range until I'm done. So I'm going to come back to that. My amplitude is 2. My phase shift would be negative pi over 3. And there's no vertical shift. That's my up-down. Okay, the phase shift is C over B, okay, where it's x minus, so that's why it's a negative there. All right, now let's do our mapping. I'm going to set the inside equal to my dummy variable, so we'll call that smiley face. So x is smiley minus pi over 3. So I'm going to take my x values and subtract pi over 3, and then my y is going to have 2 times the y. So I'm going to pause, and what I want you to do is I want you to use the mapping notation and our parent function to create a table with our 5 key points. Okay, so I'm going to pause and give you a head start on me if you haven't already done this one. While you're working, a quick reminder, tomorrow we're doing our quick quiz number 3. Then we're going to pause, and I'm going to kind of do 3 or 4 more examples of what we did today, tomorrow. You'll get a different assignment just to practice. I want to make sure that we have sine, cosine, and tangent down. So in case you're struggling to get started, let me do 2 values in the table and then still wait. If I plug in 0, 0 minus pi over 3 is negative pi over 3, and 1 times 2 is 2. When I go to do pi over 2, pi over 2 minus pi over 3, I need to get common denominators. So that's 3 pi over 6 minus 2 pi over 6. So that's pi over 6. Once you get your table, decide on how you're going to put your tick marks and then graph it. I can do my y values because all you're doing is multiplying by 2. Alright, then when you do pi minus pi over 3, that's 2 pi over 3. 3 pi over 2 minus pi over 3, I got 7 pi over 6. And then I got 2 pi minus pi over 3 is 5 pi over 3. Alright, so I decided my smallest division was pi over 6. Pi over 6 is smaller than pi over 3. So each tick is going to be a pi over 6. So every 2 ticks is a pi over 3. So please label every other tick for me. So again, I went by pi over 6's. So every 2 is a pi. 2 pi over 6 is pi over 3. So I'm going to plot negative pi over 3, comma 2. Pi over 6 is 0. 2 pi over 3 would be down at negative 2. 7 pi over 6 is at 2, or excuse me, that's at 0. Sorry. And then 5 pi over 3 is back up at 2. When you're graphing, your starting and stopping should be at the same y level. So if I started at 2, I need to end at 2. So then I'm going to go back up to my range. Now I feel more confident that that's negative 2 to 2. All right, what questions do you have about graphing with sine or cosine? Just based on this one, what questions do you have lingering? Yeah.
Why is it negative pi over 3 again?
Okay, so here's a great question. So if I have y equals a cosine bx minus c plus d, by definition, the phase shift is c over b. And the reason why is because you're setting the inside equal to 0. So if you don't want to remember b or c over b, you can always take the inside equal to 0.
Yeah.
And so since it's x plus pi over 3, you would be subtracting pi over 3, so that's why it's negative.
Right?
Yeah, that's a great question. All right, anything else you want to clarify? All right, example 5. What if I give you all the characteristics about the graph and ask you to write the equation? And I can do this in words, or I can actually give you the graph and ask you. So you can still determine the period from the graph, you can determine amplitude from a graph, and then write the equation, because you're going to see that on tonight's homework. So I'm telling you that the parent function is y equals sine x. The period is pi over 2. The vertical shift, that's the up-down, that's the d value. The phase shift is pi, and the amplitude is 4. So again, I'm going to pause a moment, and I want to see if you can come up with, and if you can't come up with all the letters, the A, the B, the C, and the D, you should be able to come up with 2 of them. And what I mean by A, B, C, D is this one here. The y equals, and then I think I asked you for sine, so just replace cosine with sine, okay? So do as much as you can, and then I'll fill it in for you. you're supposed to remember that the period for sine or cosine is 2 pi over b. Well, our period is pi over 2 equals 2 pi over b. I know how to solve this. This is a basic proportion. I can cross multiply and I get pi times b equals 4 pi. Dividing by pi, b is 4. I don't see anything about a reflection over the x-axis. So when I have the amplitude, if there's no reflection, then it's the positive value. The vertical shift is the d. Now watch this. Phase shift, and I'm really glad you asked about that phase shift because the phase shift is equal to c over b. Well, it's pi, and I just found b. So pi equals c over 4. So now I'm going to solve for c. Yeah, so c is 4 pi. So now here's the equation in general. Y equals a sine the quantity bx minus c plus d. And I'm going to plug everything in. Y equals 4 sine 4x minus 4 pi plus 3. Sorry about that. My board took on a life of its own a moment there. So, it's a 4x minus 4 pi, close the parenthesis, plus 3. So, what you're going to do when you either have a graph and you want to write the equation or you're given characteristics and you want to write the equation, you want to go through and find A, B, C, and D. And then plug them in. All right, number 3. So yesterday we did sine and cosine. Today we're going to focus mainly on the tangent graph. So this is the parent function. And similar to sine and cosine, the tangent parent function has 5 key points. And here they are. Negative pi over 2. Negative pi over 4, 0, pi over 4, and pi over 2. I'm going to pause a moment, and I want you to fill in those 5 values for tangent. And I put on my front chalkboard, there's my circle and my 45, 45 right triangle. Because pi over 4 is how many degrees? 45, okay? So use your 45 right triangle and then do your negative rotation. You're going to use 0 and pi over 2 and negative pi over 2. I also gave you some helpful things up here. The tangent theta is sine theta over cosine theta. All right, so when I do negative pi over 2, that's a rotation, negative 90. So if it's sine over cosine, that's negative 1 over 0. Well, negative 1 over 0 is undefined. Negative pi over 4, that's a rotation of 45 degrees into the 4th quadrant. So the tangent of 45 is 1, but all students take calculus. If I'm in the 4th quadrant, tangent would be negative. To do 0, the tangent of 0 is the sine over the cosine. 0 over 1 is 0. The tangent of pi over 4 is 1. And then the tangent of pi over 2, if I come up here to pi over 2, that's 1 divided by 0, which is undefined. Now, what's happening when it's undefined? Anybody remember from Algebra 2? What is that thing? What's that called? Vertical asymptote. Okay, it's a vertical asymptote. So my smallest
Gross.
division is pi
I didn't
over
say
4. So let's go by pi over 4s. Then the second tick is pi over 2 and negative pi over 2. So we're going to sketch in our vertical asymptotes. And then we're going to plot the 3 points. So I've got negative pi over 4 comma negative 1, 0, 0, and pi over 4 comma 1. The period length is how long it takes to repeat the cycle. Well, this is repeating from negative pi over 2 to pi over 2. So what is that distance? Pi. Okay, so the period length is pi. Now the vertical asymptotes, we're going to write these in general, and hopefully your Algebra 2 teacher last year did that as well. What you do for your vertical asymptotes is you choose the first one that's positive. Okay? There's infinitely many vertical asymptotes, but the convention, so that our answers can look the same, is that I pick the first positive from the origin, so that's going to be pi over 2, and then you add the period length times k, where k is an integer. So it's always the first positive vertical asymptote plus the period times k, because then every pi, in this case, it's going to give me the next one. Now, since k is an integer, k can be negative 1. So pi over 2 minus pi gives me the 1 on the left. The domain is everything but the vertical asymptotes. So the good news is you're essentially rewriting the vertical asymptote with a not equal to. My range is negative infinity to infinity because the graph goes down forever and up forever. And range are the y values. Domain are the x values. So this is the parent graph. Yeah.
So wait, what did you say the k stood for again?
K is an integer, like
Just
0,
any
1,
number.
2, 3. It's any, but it's 1, 2, 3, 4, 5, or negative 1,
Yeah.
negative 2. Yeah.
So like, where would I get that in, like, if it was an actual problem? Like for the previous one, if there's a tangent, what would be?
Well, if you stay with me, we're going to do it on the next couple, and then hopefully that'll clarify it for you. All right, note, the tangent function does not have amplitude. Why? Why is there no amplitude? Lilia? Exactly. If you remember from yesterday, our amplitude is half the distance from the maximum to the minimum. And since the tangent goes up to infinity and down to negative infinity, it's impossible to measure, okay? It does have an a value, but not an amplitude. All right, so in general, the period of f of x equals a tangent. The quantity bx minus c plus d is pi divided by the absolute value of b. So let's look at, we're going to do 3 graphs. And hopefully we'll get the vertical asymptotes down by the third one. It says, sketch the graph of y equals negative 2 tangent x. Identify the period. VA is going to be your vertical asymptote, domain and range, and identify 5 key points. So here we go. We're going to stay consistent with what we did with sine and cosine. I'm going to make my parent chart, but for tangent, those 5 x values are negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. Just look above. It was undefined, negative 1, 0, undefined. Then what we're going to do is we're going to use mapping notation. The great news is I don't have anything inside with x. So, yay, it's just x. And then what is the y going to map to? Yes, negative 2y. Okay, you're going to use that a values, not an amplitude, but the a value. All right, so I'm going to pause. And what I want you to do is I want you to use the mapping notation. You're going to write all the x values the same. But then you're going to take negative 2 times the y values. Now, undefined remains undefined, okay? So you can't take negative 2 times undefined. Alright, so here's my table. And then I just pick my smallest division, which is pi over 4s. So I have vertical asymptotes again at negative pi over 2 and pi over 2. So the negative causes it to be a reflection over the x-axis, and the 2 is a vertical stretch. Okay, so this is a little bit of algebra 2 terminology, okay? So it's a reflection and a vertical stretch. So the period is pi. The vertical asymptotes, so the very first one is pi over 2 plus, you take the period length times k, where k is an integer. And I know you might think, gosh, why do we have to say k is an integer? Well, k could be any number. I could make it 1.1, radical 3. You know, I could make it other numbers. And so it's got to stay that I'm adding pi, 2 pi, 3 pi, 4 pi. Yeah.
So the k is just like a letter.
It's a variable, yeah.
So we don't actually have to, like, in that problem, there would be no number that we would put there. We would just put a k.
Right, yeah. All right, and so the domain is everything but the vertical asymptotes. And then my range is negative infinity to infinity. All right, let's try example 7. It says sketch the graph of y equals 3 times the tangent of x over 2. So if you want to just look at the parent function, that's fine. I'm not going to bother writing it. So what we're going to do is we're going to do the mapping notation. Now I have something inside with x. So you set the inside equal to your dummy variable. So I'm going to call it smiley face. And I would need to multiply by 2. Then my mapping notation is going to go 2x, comma, 3y. So what I want you to do is once you get that mapping notation down, I want you to take the parent function, 5 key points that we have above, do the transformation, the mapping, and fill in your new table. If you're a fast worker, sketch it and try to identify period, vertical asymptote, domain, and range. Do as much of it as you can.
So if it's undefined, we still keep it
undefined. Yes. when you're done with your table, check it with mine. My smallest division is pi over 2. So this time, I'm going to get vertical asymptotes at negative pi and pi. Ooh, this one's a nice vertical stretch of 3. Now the period length is pi divided by b. So in this case, b is 1/2. So the period length is 2 pi. Doesn't that make sense? Look, between vertical asymptotes, negative pi to pi, that's 2 pi, right? Pi to the left, pi to the right, that's 2 pi. So your graph should verify, like what you're getting. Yeah.
So, say we just like, even though the pi over b is super easy, say we just didn't feel like doing that, can we just look at the graph and be like the distance in between?
Absolutely you can. It does not matter which way you do that. It does not. All right, so then the vertical asymptote. You pick the first positive vertical asymptote, which is pi, plus. Now the period is 2 pi. So it's going to be plus 2 pi k, where k is an integer. Okay, so notice it did change. The domain is x can't be where the vertical asymptotes are. The range for tangent will always be negative infinity to infinity. I don't have a vertical shift. I don't have an up-down, and I don't have a phase shift because I don't have a c value. All right, I'm going to pause again, and I want you to do as much of example 8 as you can on your own. Let's see. Let's see if you can stand on your own 2 feet now. See if I've done my job.
Where's the half from
X over 2,
Yeah.
because if I rewrite that as something times x, it's 1/2
not half,
times. It's not 2, it's 1/2.
Yeah.
All right, try example 8 again. Do as much as you can. So the homework tonight is the 4.4 worksheet I gave you yesterday. I was hoping you did part of it last night. Hopefully it's not blank. And so your job is to finish it tonight. It's due tomorrow.
So like, when we have the minus pi over 3, is that just like a shift?
Yes, it's right.
And then it would just be the parent function. It's
Yes.
right.
Yeah, yeah. And however you visualize it is okay. Like, if you don't want to do the smiley face thing, you don't have to do the smiley face thing.
Okay.
depending on where you are. Here's my table. So you had to take each x value and add pi over 3. So this got into some fraction work here. And then my mapping is x comma y. It just takes every x value and shifts it right pi over 3. So I do have a phase shift. Okay, I have a phase shift of positive pi over 3, but there's no vertical shift. The period is still pi. All right, since my divisions were 12, pi over 12, okay, this one was tricky. So I went by 12ths, but it really stretched it out. Because then I did every other tick was pi over 6, so then that's 2 pi over 6, which reduces to pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6 is 2 pi over 3. Then I have, what, 5 pi over 6, 6 pi over 6, and then 7 pi over 6. And I'm going to make every other tick up here the 1 and negative 1 so I can see it a little better. So at negative pi over 6 was a vertical asymptote, and at 5 pi over 6 was a vertical asymptote. Then here's pi over 12 was negative 1, pi over 3 was 0, so then my vertical asymptote, the first positive vertical asymptote is 5 pi over 6 plus my period times k. Then the domain is x can't be that value. The range is negative infinity to infinity. Again, my period length was pi, and I did have a phase shift of pi over